Hey guys, we're going to take a look at what's called negative exponents today, and we're going to kind of follow a pattern and logically prove something, and just stay with it. And we're going to just use this. This is not as complicated as it looks, but when you look in your book and you see things like x's, and then we have exponents on the x's, and then we have negative, like x to the -4 and all that, it starts looking really complicated. But if you break this down, negative exponents and all that, it simply is addition and subtraction. I got two questions for you. Can you add 7 plus -2? Sure you can. Okay. Can you add 3 plus 8? Of course you can. All right. And the second question is, and I guess that was two questions. Can you multiply 3 and 5? Well, of course you can. Can you multiply -3 and -8? Yes. Okay, that's all you're doing. This looks complicated, but it turns out to be, when you break it all down, you boil away all the nonsense, it's just adding and subtracting, and that's it. And there's one basic rule that you're going to have to learn about negative exponents. Once you get that, it all becomes a piece of cake and everything is just moving and adding and subtracting. That's all there is to it. But let's go down the list and just look at what happens here. All right, we know the answer to 2 to the 3rd power, right? It's 2 times 2 times 2, which is 8. All right, now what I'm going to do is I'm just going to take this exponent and go down, 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 down each time. All right, we need to logically follow the answers and see what happens, okay? 2 to the 2nd power is 4, right? 2 times 2. 2 to the 1st power is 2. Now let's stop right there. What is happening each time to these answers? They're being halved, right? So each in half, okay? So when you come down to 2 to the 0 power, don't say 0. Okay, we have to logically follow the pattern. Half of 8 is 4. Half of 4 is 2. So 2 to the 0 power must be half of 2, which is 1. All right, we'll prove this in sometime in the future. All right, let's look at this. Now we've gone from 3 to 2 to 1 to 0 to -1. Okay, now what's the answer to this? Don't say -2. We have to follow the logical pattern. We are going down each time, each time, each time. 3, 2, 1, 0, -1. Each time the answer is being halved. 8. Half of 8 is 4. Half of 4 is 2. Half of 1 is 1. And the answer logically has to be a half, right? Half of 1 is a half. And here, it has to be half of a half. In other words, half times a half is a 4th. And then half of a 4th is an 8th, and so on. Now look at that. Do you notice this here, the relation between this and this? 2 to the 3rd power is 8. 2 to the -3rd power is 1 over 8. Now look at this. 2 to the 2nd power is 4. 2 to the -2nd power is 1 over 4. And you can do the same thing here. 2 to the 1 power is just 2. In other words, 2 over 1. And 2 to the -1 is, we move that down there, and it's 1 over 2. Okay, this takes us to our rule that we want to make sure you memorize. If you need to write that down, absolutely write that down. And this is basically it. X to the -n, n can be any number in the world. That is the same thing as 1 over x to the positive n. Okay, and if you want to think of it this way, there's another way to think of it. What you can do is you can go, okay, x to the -n is the same thing as going like this and moving this down to the other side of the fraction, in this case going from the top to the bottom, and then changing the sign of the exponent. Notice it doesn't change the sign of the x at all. At all. It only changes this -n to a positive n, and that is it. Because look, 2 to the 3rd power, well, if you do 2 to the -3rd power, that means you're going to go 1 on top of 2 to the 3rd power, right? If it's 2 to the -3rd power, is that. That'll be 1 over 2 to the positive 3rd power. Okay, let's do a couple of examples here. 3 to the -4th, well, by definition, that's going to be 1 over 3 to the positive 4th. All right? And if you want to go ahead and do 3 times 3 times 3 times 3, that's the same thing as 9 times 9, which will be 81. How about that? Okay? How about this one? 7 to the -2 power. Well, by definition, that's going to be the same thing as 1 over 7 to the positive 2 power. Now again, notice, we're not messing with the base. 7 stays the same, 3 stays the same. Only the exponent are we changing the sign of. All right? And of course, we know that 7 to the 2nd power is 49. Here's another one. 6 to the negative third power? Well, I mean, that's just going to be 1 over 6 to the positive third power. We don't care what that is at this point. All right, how about 1 over 5 to the negative 8th power? Now, that's kind of a weird one. And here's something strange. Let's go ahead and find out what it is. Let's do exactly the same thing as we just did before. We will say that this is going to, okay, 1, leave it alone. This here, we're going to rewrite as 1 over 5 to the positive 8th power, right? Like that. Well, you know how to divide a fraction by a fraction, right? In other words, what is 1 divided by this? It's the same thing as 1 times what? This flipped, right? Well, this flipped, the reciprocal, is just simply 5 to the 8th power over 1. We don't need to write that. So this is just going to be 5 to the 8th power. Now here's another way you can look at this. I started to mention it before, but let's look at it this way. 1 over 5 to the negative 8th. What you can do is, as a rule, anytime you see negative exponents, you can move them from the bottom to the top, or you can move them from the top to the bottom. If you move it from one to the other, in other words, from the denominator to the numerator, you will change the sign of the exponent. You will not change the base, only the sign of the exponent. So we proved that this is the answer by going through and doing all this division gobbledygook, right? Well, another way we can prove this is just to say like this. I'm going to go, whoop, that goes up here, yoink, and this becomes not 5 to the negative 8th, but it becomes 5 to the positive 8th over 1, which we don't care about that. And divided by 1 is just going to be 5 to the 8th. So there we go. That's the rule. Rewriting an exponent, you write this down if you need to. This is very important. You want to make sure you understand this, okay? And I'll go ahead and pause it if you need to. You can, number 1, flip the number with the exponent from denominator to numerator or vice versa. In other words, if it's here, it goes down to the denominator. If it's in the denominator, up to the numerator, okay? Flip it. Secondly, change the sign of the exponent, not the sign of the number, the base, the bigger number, okay? And that's it. That's our rule, okay? We already proved back here that this works. So why sit there and have to divide, then flip the fraction every time? Just do this. Go yoop up there and just change the sign of the exponent. You're done. Don't go through all that rigmarole. Make it easy and fast on yourself, okay? So for example, we can go like this. Anytime you see a number like this, you can always go, oh, it's over 1. Anything in the world is a fraction over 1, all right? So you can say, all right, I'm going to rewrite this. I'm going to go, this goes down here, and this becomes 3 to the positive 2, and we still have a 1 up there. There's not going to be a 0 there. It'll be a 1. Okay, and we can go, well, a 1, 3 squared is 9. That's my answer. Here we go. Okay, here's another one, right in the middle of what I was doing before. All right, 1 over 3 to the negative 3. Well, here, very quickly, let's just do this the long way. Okay, 1 over 3 to the negative 3. Well, 3 to the negative 3 is the same thing as 1 over 3 to the positive 3, right? 3 to the third power is 27. Okay, so our problem is, what is 1 divided by 1/27th? Well, how many 1/27ths go into 1? Obviously, the answer is 27 of them do, right? So all you need to do is just to do this the short way. You don't want to do it that way. Just plop this, go up there. That's going to be a 3 to the positive 3. That just becomes a 1. 3 to the positive 3 is 27. Our answer is 27, just like we said over here. Easier way to do it. How about this one? This is where it starts looking complicated, but if you just take your time and make sure you're good, nothing bad can happen to you except for maybe you pull your hair out or something like that. All right, here we go. All you need to do, if you ever get confused, is just simply write this over a 1, and that will turn into, same old rule, 1 goes there, this goes down here. Remember, don't change anything except for the sign of the exponent, not the base, nothing else. So I keep my parentheses, and I only change the 2, from a negative 2 to a positive 2. Well, you know what negative 3 times negative 3 is? It's 9. There's my answer. All right, here's another one. Probably right on top of that one too. Well, I think I can do this. 4 to the negative 1 power. And again, anytime you see a number, it's always over 1, if you want to think of it as a fraction. This can just go down here. So it becomes 1 on top, and then 4 to the positive 1 power on the bottom, well, that's just 4, so the answer is 1/4. Here's another one. 1 to the 5 over the negative 2. Well, if you notice, this is kind of the same as this one here. You can still see it under all that red. All we need to do is go, that goes up there. The 5 stays the same. The negative 2 turns into positive 2. Well, 5 squared is 25 over 1. There you go. That's all there is to it. Okay. We know this. You tell me what the answer to this is. Okay, oops. We've done these before, right? 2 to the third times 2 to the first. We just add those, right? So the answer to that is 2 to the fourth. Okay, here's another one. X to the third times x to the seventh. What's the answer to that? X to the 10th, right? Okay. How about this one? X to the negative 5 times x to the 2. Now, we haven't done negatives yet, have we? But who cares? You know how to add 3 and 7. You also know how to add negative 5 and 2. In other words, if they had a question for you in your math book that said, what is the answer to this? Negative 5 plus 2. You would go, negative 3. So, fine. The answer is x to the negative 3. Now, if they told you they wanted you to write that as a positive exponent, you would just go, okay, well, I know that's over 1. I'm just going to knock that down here. That turns into x to the positive third, and there's a 1 up top, and there's my answer. That's what you do. Here's another one. Y to the 7, y to the negative 9, y to the negative third. Well, I mean, you know, all you need to do, this is just addition. This looks complicated, but it's just addition. What is 7 minus 9 minus 3? Well, 7 minus 9 is negative 2. Negative 2 minus 3 is negative 5. So the answer is y to the negative 5. And you can leave it like that if you want to, unless they give you other instructions or whatever. Okay, how about this one? P to the 5th times p to the 12th times p to the negative 7th. Well, p to the negative 5th times p to the 12th, that's negative 5 plus 12 is 7. So that's p to the 7th. What is p to the 7th times p to the negative 7th? P to the 0, right? Which is, by definition, 1. All right, I don't know if you remember back here, several slides back, we did this, you know, where are we at here? This one here, 2 to the 0 power is 1 by definition. All right, look at this very quickly, I'll show you. If you were to do this, for example, and you were to go like this, I'm going to leave my p to the 12th where it is. And of course, we know that this is a fraction over 1, right? We can just put a 1 there if you want. If you move this p to the negative 5th down here, this would turn into p to the positive 5th. And if you turn this p to the negative 7th down here, it would turn into p to the positive 7th, right? Well, you tell me. What is p to the 5th times p to the 7th? P to the 12th, right? So there's p to the 12th on the bottom. This is gone. Well, what is p to the 12th divided by p to the 12th? Anything divided by itself is, there you go, it's 1. One last one, or a couple more, I guess, not on that page. Okay, here's where we get to the point where we go, okay, we're going to simplify these. And they will say, simplify this. And this is kind of like, you know, what we've done before. We're just going to use negative exponents. So we're just going to, if you need to pause it, go ahead and pause it and copy it. And we're just going to plop all the x's together and then plop all the y's together. And when we're done, I mean, excuse me, m's together in this case. So x to the 4th times x to the negative 2, that's going to be x to the 4 plus negative 2, or just 2. And m squared times m to the negative 5th will be m to the 2 plus negative 5 is negative 3, and that's it. And they might tell you, write all the answers with positive exponents. And you'll go, okay, well, fine. If they do that, let's see, this is over a 1, and I can just move that down there, and that turns into m to the what? Positive third, right? And then that's gone. And there you go. It's x squared over m to the third. That's my answer, if they ask you to do it with all positive exponents. Here's another one. Pause and copy this down. Okay, well, same thing. Let's just get all the x's together, the y's together, and the z's together. And we're done. So let's go x to the negative 2 and x to the positive 4. That'll give us x to the negative 2 plus 4 is 2. Okay? So we got y to the negative 6 and y to the 5. Well, negative 6 plus 5 is negative 1. And oops, we forgot an x there. Look at that. We forgot an x. So I'm going to have to make that an x to the third power. Okay, we forgot an x. I shouldn't say we forgot an x. I should say you forgot the x. You forgot to remind me. It's somebody else's fault. Okay. All right. We have a z there, and we have a z to the 5th, and that gives us z to the 6th. Okay. And again, if they told you, we want you to write this with all exponents that are positives, you would say, okay, well, this is the way it looks right now, the 1 down there. If I move this y to the negative 1 down here, it would turn into y to the positive 1. You don't even have to write a 1 if you don't want to. Boom, there you go, right? Okay. 0 exponents, we kind of went over this a minute ago, but let's just prove this, okay? If you have 4 squared divided by 4 squared, obviously the answer is 1, right? 16 divided by 16 is 1. If you were to actually take the, the exponent and use that as part of the problem, you would go 4 squared over 4 squared. You would go, okay, look at this. If I pull this up here, that'll give me, this part here will give me 4 to the negative 2, right? So here's my new problem. 4 to the 2, 4 squared times 4 to the negative 2. Well, then that would be 4 to the 2 minus 2, which is 0, right? We already know that the answer to this is 1. Anything divided by itself is 1. So by definition, something divided by itself is 1. And by definition, anything to the 0 power, like this, is also 1. Okay, we did that at the very beginning of this exercise. Okay, oops, let me get this out of the way. And again, anything divided by itself is 1. If you were to move this 3 up here to the 3rd power, it would turn into 3 to the negative 3rd. And then 3 plus negative 3 is 0. So your answer is 3 to the 0 power, which is also the same thing as 1. Same thing there. It's all 1. That is what you want to remember. In case you forgot that. Okay. All right. Do it. If you have good speakers, just blast it and just go like really loud. Your mom come running down. What's going on down here? Math, mom. Saxon math. Okay. Write that down if you need to. By definition, anything to the 0 power is 1. Okay, let's look at this one. So pause and copy if you need to. And we're going to simplify. So x squared, and we have x to the negative 2. Well, look at that. 2 minus 2 is 0. So the answer to that is x to the 0. Well, that's just 1. And we have y to the 5th times y to the negative 2. That's going to be y to the 3rd. Don't even bother to write x to the 0. What's the point of writing 1 times y third? Is, who cares? All right, leave it. Okay, here's another one. Pause and copy that one down. Well, we've got m to the 5th, and we have m to the 1st. That gives us m to the 6th. Now we have b squared times b to the negative 2. Well, that gives us b to the 2 minus 2, or 0. By definition, that's 1. There's no sense in writing m6 times 1. Just write m to the 6. You're done. Okay. Here's another one. Now look at this. This is again where you, oh, it's so complicated. Oh, whatever. It isn't. Don't forget. All you were doing. I mean, do you know how to use a distributive property? Yes, you do. Do you know how to add numbers? Yes. Do you know how to add positive and negative numbers together? Yes, you do. No big deal. Let's just do it. Okay. Let's take care of this first. I have x to the 5th. Nothing goes along with that. So just put x to the 5th. Y to the 0. What is y to the 0 by definition? 1. I'm not going to bother to write 1 times this is that. Forget it. That's gone. Done with that. That's z to the 1st, by the way. There's nothing else to put along with p, so just put p to the negative 3. Now we have z to the 1st times z to the 0. Well, what is z to the 0 power by definition? 1. That's going to be z, or z to the 1st power. We're done. Minus, okay, and that's a 1 times a 4, which is a 4. X to the 5th times x to the negative 5th is x to the 0, which is by definition 1. I'm not going to write 4 times 1. What's the point? Z to the 1st times z to the negative 1st is z to the 0, which is by definition 1. I'm not going to write 4 times 1 times 1. It's pointless, okay? Just write 4. You're done. That's all you got. Finished, all right? Here's another one. Pause that and copy it. Well, you can probably look at this and go, okay, let's do this first. You go x to the negative 2 times x to the 2nd, 1. X to the 0. Y to the negative 2 times y to the 2nd, y to the 0, 1. Z is the only thing we have left, so that's all we have left there. Z, done. A positive times a negative is a negative. A 1 times a 4 is a 1. X to the negative 2 times x to the positive 4 is x to the positive 2. Y to the negative 2 times y to the positive 2 is y to the 0, which is 1. No point in writing that. Z is there too, nothing to go along with, so yoink, there we go. We're done. That's all we got. That's all we have right there. All right. Okay, let's do this. These are 0 exponents. We've talked about this before. By definition, something to the 0 power equals 1. All right, now this one is slightly different. We're going to this time, if there's a negative hanging off the end of it, we're going to take care of this part first. We know that this right here is 2 to the 0 power is a 1. When we're finished figuring that out, we just go ploink and plop the negative onto that. So the question they're asking in B is, what is the opposite of 2 to the 0 power? And your answer is, oh, that's the opposite of 1, which is negative 1. All right. If you have things in parentheses to the 0 power, it doesn't matter if you have negatives inside there. Everything is shut in by those parentheses, and it is being applied to the 0 power. The answer is 1. I don't care if it's this, x to the 6, z to the 1,000th, y to the negative 40 to the 0 power. I don't care what's in there. That answer in parentheses is 1. I mean, you can, I don't care if you have, you know, you got a picture of your grandma in there, okay? She's very skinny. She has a plate of cookies. These are gluten-free, goat milk, homeschool cookies. If she is in a set of parentheses and she's to the 0 power, the answer is 1. Okay, and you can tell her I said so. No, don't tell her that. Okay, all right. Write that in your next letter. Grandma, we found out what you are to the 0 power. Okay, if you got parentheses, the answer is 1. If you got something like this, take care of this first, then apply the negative. Boom, you got it. Okay, all right. Try your practice set and try A first, and then come and go ahead and pause it and see what the answer is. Okay, A is 2 to the 3rd power, or in other words, 2 times 2 times 2, or 8. Okay, pause it and try B. B is 1 over 16. Okay, don't forget, you flip, you know, and you will change the sign, not of the 4, not of the 2, not of the 3, not of the base. You change only the sign of the exponent, 1/16. All right, go ahead and pause it and try C. C will be the opposite of 3 in parentheses squared, which is the same thing as negative 3 times negative 3, which is 9. Okay, pause it and try D. All right, D is just 1. 1. All right, pause it and try E. Okay, E will be negative 1. Pause it and try F. F will be 1. Pause it and try G. G is also 1. Hey, all right, one more to go. Pause it and try H. H, broken down, will be x to the 3rd, y to the negative 3rd, and z to the 6th. And one of these days, if they ever ask you, you know, write these all with positive exponents. Okay, well, all you'll need to do, this is the only one that has a negative exponent, so you just go boink down there, and that becomes y to the positive 3rd power. You cross that out, and you are done. Okay. I'm just kidding. There's I next. Pause it and try I. Okay, I is x to the 8th power, and our very last one, pause it and try J. There's your J. Okay, you've got that distributed out and so forth. So, okay, all right. Any questions on these? Do some more. You'll have plenty to do this problem set to practice those. And again, don't get intimidated by these. Don't look at your problem set and go, oh gosh, look at all that stuff. All of these are adding like terms together. You're using the distributive property, and you're adding numbers like 8 and negative 11, or you're just going from one to the other, and you're recognizing that you can go like that and change the sign of the exponent. Okay, y'all have fun with that problem set. I know you will. See you next time. Y'all take care.